So, dear student, today I will be taking the chapter 3 of physics, laws of motion. Okay, so we won't be doing the problems, but I'll be explaining you the theoretically what it is. So, this is the third chapter. So, first thing for us is the basic things, that is, what is force? Correct. So, we all know what is force, push or pull, and all of those definition already we have been studying from class 7th onwards. Correct. And the type of forces, obviously. Muscular force. So obviously it involves the action of muscles. Correct. Obviously, human beings as well as animals use what? Muscular force for doing their physical activities. Then frictional force, friction. Correct. So obviously, friction depends on what? For example, if you're driving in a car, wheels on the road. Correct. Yeah. So there, it's a smooth thing. So the rubberized wheel will be able to make the car go in a very smooth, but still there will be some friction. But just imagine, instead of rubber, if there is a metal, there's only metal cover of the car, then what will happen? There will be a fire, right? The sparks, correct? So there will be a friction. Okay, so the force between the two things. So that's basically a friction. Tension. Tension force is nothing but, if we all know about the simple pendulum. The pendulum we know. Correct. It will go like this and it will come back, right? Correct. So the force appearing in a string attached to a rigid support. So pendulum will have a support, correct? And it will be going this side and that side, respectively. Mechanical force, obviously, it is the force generated by the machine. Then force exerted during the collisions. So collision in the sense, for example, let's take again, I will take the example of vehicles, correct? The two cars are getting collided. Correct. Obviously, if one car is moving at 30 kilometer per hour and another is moving at 50 kilometer per hour, unequal speeds, correct? So there will be obviously what? There will be a collision. That kind of collision is called inelastic collision. I'll just write down here, which is not there in your textbook. Inelastic collision. What is there in your textbook will be the normal collision. So this again is there in your class 11th, not now. There is inelastic collision. Now what we are having is the normal thing. See, for example, two objects push each other with equal but opposite forces. Equal and opposite forces. So equal and opposite forces, we don't have, see, coming to this thing, if I take the practical example of this, what is it? Let's take the two cars. Obviously, both the cars will not travel in equal speeds. Okay. And for students, whatever doubt is there, I'll be clearing at the end. Okay, once I take the class, I'll be finishing it off and I'll be clearing all the doubts. And I'll be giving you much more examples regarding the same. Okay. So coming to the force exerted during collision, that is two objects push each other with equal but opposite forces if collision occurs between them. So practically that is not possible, because only in theoretically it is possible. Practically, as I told you, we only have got inelastic collision. Okay, so there are two types of collision. One is elastic collision, and the other one is inelastic collision. Okay, so again, all of these things in detail we will be studying in class 11, not even in 10th. Combined forces, I think, where two or more forces are acting on the same object, that is called the combined force. Then comes the magnetic force. So magnetic force, obviously, between two magnets or between a magnet and a magnetic material. So we know what is a magnetic material, like irons, cobalt, steel, nickel, and all. Those are all non-magnetic. Those are all magnetic material. So it can be either attractive no or repulsive. Then electrostatic forces. Forces due to electric charge. Okay, force due to the electric charge. Okay, so that also is one kind of force. And gravitational force, I think we know. Just as I told you, due to the Earth's gravitational pull, the force happens. Then the first law of motion. So a body at rest remains at rest, and a body at uniform motion continues the uniform motion unless an external force applied. For example, let's imagine that we are all playing football. Okay, so the ball is there. Somewhere, let's say in this particular room, one ball is there on the corner. It's just lying it down. Without me kicking, will the ball move by itself? No. So that is only my first law of motion. In the sense, one more example for this is, for example, let's take today's climate in Bangalore. I think kind of rainy day, right? The climate is also kind of, what would I live? It's cozy climate in the sense it's no, we have to sit and relax, the relaxation climate. So now if you're at home, we need some external push for you to study. Some motivation is there, correct? Some external force is required for us to take the action. Without that, we might study, we might not study. But the ball, again, we are human beings, we will study, we will not. That is secondary. But coming to the object like ball, without me kicking or you kicking the ball will not move. So an external force is required. So that is the thing. This is from this only actually the important things start for our subject. Rest everything is dummy, whatever I told. From this only the actual thing starts, from the first law of motion. Say a body at rest remains at rest, and a body in uniform motion continues its uniform motion unless an external force is applied. Okay. Then inertia. Fine. In the sense, let's imagine that we are going in a bus, moving bus, and we are standing. We are standing in the moving bus. So suddenly what happens? The driver is putting a brake. So we will tend to come forward and then comes backward, right? Yes. But when when the bus is moving, we'll be actually in what? In a stable position. Correct. But suddenly when they're going to put the brake, suddenly what is happening? Our state is also changing. Correct. So our body will try to resist that change. You got the point. Yes. So that is nothing but the inertia. So it is a tendency of the body to resist any change in its state of rest or of uniform motion along a straight line. Okay. So that is nothing but our inertia. So type of inertia, we got two things, inertia of rest and inertia of motion. Okay. And again, we will study in detail. Then coming to the next one, momentum. I'll try to put it in a triangle. Momentum. Put it here. So now I'll explain what is this triangle. One second. This P is only my momentum. This P symbol is only my momentum. M is the mass and V is the velocity. So momentum, I will represent it as P. Okay, P. Fine. So my P is my momentum, M is the mass and V is the velocity. So remember the triangle. So P is equal to what? Mass mv, mass into velocity. So momentum is equal to mass into velocity. Okay, and mass, what is it? The unit of mass is what? Kilogram. Unit of mass is kg, kilogram. And what is velocity unit? Meter per second. What is velocity unit? Meter per second. So I will draw this thing also. Kilogram meter per second. That is the unit of momentum. So remember the triangle. And triangle, how to remember? Always remember what is there on the top. On the top, what is there? Momentum is there. P is there. That you remember. Clear? I think this is an important point which I have to teach. Yeah. So I hope it's clear. And even if you're not writing, I'll be sharing you the link on session is over. So no need for it to worry. Yeah. Again, the second law of motion. So second law of motion says when a force F is subjected to a body of mass M and acceleration A is gained by the body in the direction of force and magnitude of acceleration directly proportional to the force and inversely proportional to M. In the sense, the second point, rate of change of momentum is directly proportional to applied unbalanced force. This is my second law of motion, or it is also called the law of momentum. Rate of change of momentum is directly proportional to what? Applied unbalanced force. Okay. In the sense, what is my force? Mass into acceleration. Unit of force is Newton. What is force? Mass into acceleration. Are you learning this for the first time? Let me know. A physical MA. Are you learning this for the first time or have you learned it before? Please mention the chats. A physical MA. Are you learning for the first time? First time. Okay. So again, draw triangle if possible here. Let me draw it again. Yeah. Again, on the top, what should come? Force should come. F. And here M. And here A. F is force, M is mass, A is acceleration. A physically MA. Sure. Second law of motion. If you have doubt, I'll again explain you. Okay, 1 second. Let me take it. See, second law of motion, for example, if you're having difficulty in learning, let me just put it here. Yeah. If you're having difficulty in learning this particular definition, you can just simply write it down. I'll write it down for you. This force, F is equal to MA is there, right? Correct? F is equal to MA, M into A. Correct? You can write that the force applied is equal to the product of mass and acceleration. Okay. The force is equal to what? The product of mass and acceleration. Yeah, I think that will be better. Rather than learning the very difficult thing like the above, basically it is F is equal to MA. That's it. As you can see here, whatever I told, the same thing only they written down. The second law of motion says when a force F is subjected to a body of mass M, an acceleration is gained by the body in direction of force. The magnitude of acceleration is directly proportional to force and inversely proportional to M. So if you're having a doubt in this, and they're telling something called inversely proportional and all, right, I think that's where you might have got confused. Very simple thing only, I'll tell you. The same equation, what is my acceleration from this equation? F by M, F divided by M, is it correct? Acceleration is F by M. From this equation, what is acceleration F by M? Is it correct? Yes. So my acceleration is directly proportional to force and inversely proportional to mass. My acceleration is directly proportional to force and inversely proportional to mass. Is it correct? Yes. So that's the same thing they told. Where, but in a difficult language, that's it. So force is directly proportional to mass and acceleration is directly proportional to force, but inversely proportional to mass. The same thing only they have told here. Okay, but in a difficult language. Magnitude of acceleration directly proportional to force and inversely proportional to the mass. Now, is it easy? So if you know F is equal to ma, you can write this second law of motion by yourself. Now, is it easy now? Yes, that's all. So basically, my second law of motion is what? F is equal to ma. That's all. Third law of motion is very, very easy. Okay. And we can relate very fast. So let's take our studies only in this. So a student who studies more, correct, or who reads more and gains more knowledge will obviously get what? More marks. And a student who doesn't study anything, okay, he just goes to school and then just come back and next day again going to school, and he can't expect 995 or 100 if he doesn't listen in the class also. So every action has got an equal and opposite reaction. I think, have you heard this thing before? Every action, there is an equal and opposite reaction. So if I study more, I'll get more marks. If I don't study more, I will not get that much. Have you heard it before? I think already you might know it, this thing. Yes, this is only my third law of motion. This already we knew, correct? But Newton is also saying that there is this, he also has proposed it. That's all. So this is the last one. Then universal law of gravitation. F is equal to G m1 m2 by r square. This capital G is called what? Not the acceleration due to gravity, gravitational constant. What is it? Gravitational constant. So there is a value for that. It is not the acceleration due to gravity. It is called gravitational constant. And m1 and m2 is masses of the objects. And r is the radius. Okay. Now let me just. This is the value of the gravitational constant. 6.67 into 10 power minus 11. Newton meter square by kilogram square. Free fall, correct? Free fall, this F is there, no? F is equal to ma, right? So instead of this gmm by r square, okay, gmm by r square, this is. So the earlier F is equal to ma. F is equal to gmm by r square, I told you, right? That is only the written here, F is equal to mg. Mg is nothing but acceleration due to gravity. Then for upward motion, as I already told you, upward motion, the lift example. If you're traveling through a lift, work is done against the gravity. That is upward motion. Work is done against the gravity. So we will be taking minus. And the velocity of the highest point will be 0. Downward motion. Correct? Downward motion. Obviously, it is towards the gravity. So it is positive. And for a freely falling body, we will take the initial velocity as 0. Then one more thing is we already studied something v is equal to u plus at and all, right? Remember, v is equal to u plus at, v square is equal to u square plus 2as, correct? So upward motion, what will happen? Every positive will become minus, that's all. Rest everything is same. For downward motion, all the laws, whatever is written is plus. Clear now? Now mass and weight already I have discussed. Scalar and vector. Correct. Mass is what? Mass is scalar or weight is vector. Weight will change. So that's the reason weight of the object on the moon is what? 1 by 6 times the weight of the object. In the sense, if I'm having 100 kg, if my weight is 100 kg on the moon, it will be what? 100 by 6 kg. That's it. So 100 by 6, let me check what is the value coming. 16.66, 17 kgs. So my weight will be just 17 kgs on the moon. That's all. Fine then.